Good old Ann. All right. Suppose this mass begins from rest. I would probably mentally underline the word from rest. If blah, 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 and blah, 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 it wants me to find time. So before I even jumped in, I said, okay, I guess VI is 0. D equals 4.8. What else do I need if I want to find time? Yeah, I said, even though this question is saying find time, I'm going to spend most of my time finding the acceleration. We're on a ramp. I'm going to do a free body diagram. So I started out by going like this. I usually go through the bottom of the ramp just because that gives me one extra 90-degree angle, lean it so I can visualize everything fits together. And I always put the MG on the pointy side. Now, what I'm seeing a lot of people do, look up, when they're drawing the perpendicular component, they're drawing it like that. Or they're drawing it like this. You want to try and make it so that you're perpendicular to that line. That's what the perpendicular component is. You're perpendicular to the ramp. So I'm going to change colors. Then I had somebody today ask me, Mr. Dewick, how do I know when to stop? Well, I know that the other component has to be parallel to the ramp. Parallel to the ramp. So I'm imagining that in my mind. I'm going to stop when I get right to about there. If I drew this line longer or shorter, that would also determine when I stop. But for now, I'm imagining that parallel line and I'm going, yeah, I'm going to stop right about there. Read, I'm going to label these. Worth doing. And yes, I caught you on your phone again without even looking up. I'm going to label these. Worth doing. This is a 90-degree angle. Color, 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 color. Color, 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 color. Now I continue. Normal force. The normal force is also, Keegan, going to be at right angles to this surface. If you drew the normal force like this, you're going to end up in yuckiness. Or I saw someone draw the normal force like this. That would be if we were on a flat surface. The word normal means at right angles to. The normal force is going to be at right angles to, and in fact, it's going to be the same size as mg perpendicular. When won't it be the same size as mg perpendicular? On the ramp questions on your test, it won't be. When would it not be on a ramp? Like this question here. Where is it, Mr. Duke? Number 4 from lesson 8. Somebody was asking me about number 4 from lesson 8 today. I forgot to zoom in. Let's do that again. I will not give you one this tough on your test because I've given you a ramp, and so you already have forces at angles and then another force at another angle. Keegan, I won't do that. I will give you a lawnmower question, and in a lawnmower question, that's the other situation, like this, or like this, where the normal force will not be equal to mg. It'll be everything down has to equal everything up. But I'm not going to give you a wonky normal force on a ramp. Too much work. So I know the normal force is the same size as mg perpendicular. Does this question want me to include friction? Yep. Well, which way is friction going to point? I don't know. I have to ask myself, which way is this sliding? It says it's sliding down the ramp, so friction is pointing up the ramp, and I'm pretty sure it's smaller than mg parallel. Now, eventually I'm going to find time. Eventually I'm going to find time, but first I'm going to find A. And so who's winning? I think people are trying to take too many shortcuts, and maybe that's my fault. Because when I did these lessons, I think I assumed things were going better than I thought than they were, and I took too many shortcuts. So I'm going to go very meticulous. Who's winning? mg parallel. Who's the loser? Friction. What's that going to equal? ma. Now what would I do? I would go mg parallel minus mu times the normal force. That equals ma. I know parallel to lines is, I'll get to that, but I would deal with the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force, mg perpendicular. I would probably go mg parallel minus mu mg perpendicular equals ma. And I just had an aha moment because, Madison, is there an m in the first term? Is there an m in the middle term? Is there an m in the last term? And the m's are going to cancel. Now, if you didn't, that's fine. You'll still get the right answer. But I happen to notice, hey, bonus, I can do that, so I don't have to divide by m. Now I'm going to do the trig. It's going to be 9.8 sine whatever theta is minus, well, you know what? I'm plugging in the numbers, Mr. Duix. Let's do that. What was theta? 53? Sine 53 minus, what's mu? I don't know what's mu with you. 0.44 times 9.8 cos 53. That equals the acceleration. Mistakes that I've seen as I've been looking over your shoulders. There was one person this morning, why am I getting the wrong answer? They'd forgotten that 9.8, and it's understandable because their brain mentally had checked off, you already typed a 9.8, you already typed it into your calculator. She'd written it, she'd forgotten to type it. That happens. So be very, very, very meticulous. I get an acceleration of 5.231, and because this isn't my final answer, I'll carry some extra sig figs. Let me make sure I type that in right. I think I'm right. Is that right for the acceleration? 5.23 and change? I'll go 5.2316. 5.2316 meters per second squared. Is this block slowing down or speeding up as it goes down the hill? I don't think it's slowing down because it didn't say it comes to a stop. So I don't need to make this negative. If it was slowing down, I would need to make this negative in the next step because now I'm going to find t. Well, I think I'm going to use d equals, vi was 0, right? So I think I'm just going to use d equals a half at squared. Am I going from memory? Yeah. So t is going to be 2 times d over a square root. It's going to be the square root of 2 times, what was d, 4.8? Over, I'm going to write 5.2316, but you know I'm using my answer button. 2 times 4.8 divided by answer button, square root. Do y'all get 1.35? Now, because it's 1.35, I would probably accept 1.34, 1.36. The third sig fig, I'm usually, as long as you're within 1, I'm good at, but we should be matched, the first 2 sig figs for sure. So, 1.35 seconds. If you got that, first of all, this question on your test, if it was on your test, would be worth 7 marks, so I can give out lots and lots and lots of part marks. But if you got that, 4 out of 4. Otherwise, I would probably go something like this. Half mark if I saw that. Half mark if I saw that. Half mark if I saw the numbers, I think. And then a half mark for finding A. Then I would probably give you a half mark for that, a half mark for that, half mark for the numbers, and a half mark for the answer. But if you got it right, 2 out of 2. There's going to be a question something like this, but it won't be identical. So what else could I do? Oh, instead of having it slide down the ramp, I could have it slide. Which way would friction be pointing then? Yes. So my equation would not be winner minus loser. It'd be winner plus winner, because they're both in the same direction, equals ma. Oh, that's going to slow down really fast. You'll get a big acceleration, a deceleration later on. But yeah, a big acceleration. What else could I do? I could have it at rest in equilibrium. Then instead of winner minus loser, you could say, oh, these two are equal to each other. So those are the mixing and matching I think that I can come up with. Number 2. Find the magnitude of the acceleration. This is the job for a free body diagram. I have M1G tension, M2G, tension. It didn't give me M1, so I'm going to find the acceleration by just writing an equation for M2. It told me M2 is accelerating down, so my equation must be M2G is the winner, tension is the loser. That equals M2A. And it wants me to find the acceleration. Oh, they gave me the tension. I'm just going to divide by M2. A is going to be M2, 5.9, G, 9.8, minus 35.4, all divided by 5.9. Bracket, 5.9 times 9.8 minus 35.4, close bracket, divided by 5.9. I got it. Oh, nice. 3.8 meters per second squared even? Is that right? I always get suspicious when it works out to a nice number because I usually don't care enough to do that for you, so that's a fluke, but okay. I would give you 1 mark for that, half mark for the numbers, half mark for the answer, but as always, if you got it right, 2 out of 2. Find M1. Now I'm going to write an equation for M1. Which way is M1 accelerating? Up. So Lena, which force here is winning if M1 is accelerating up? Which force is losing? This is going to be my equation. Tension minus M1G equals M1A. If you're doing the ultimate review, some of the missing mass questions, you won't find that you have 2 M's, you only have 1 M, in which case you can just get the M by itself. But here, how many M's do I have? How many would I prefer? 1. First thing I would do is I would get them all to the same side. I would write this as tension equals M1A plus M1G. What's the clever trick? Okay. Who's in pre-calc 12 right now? I think you're just starting to do log equations. So if you're solving, look up something like this. 3x log 4 minus 2x log 7 equals 12. How many x's do you have? How many would you prefer? 1. Write it like this. And now, how would you get the x by itself? How would you move the bracket over? Divide. Some kids turn these into decimals, but the problem is they're non-repeating yucky decimals. You're going to be rounding off. You're going to turn this into a decimal. You're going to be rounding off. So I don't do it that way. I would say get the x by itself, use Math 9. Why not? Much cleaner. Back to here, I'm going to write this as T equals M1 bracket A plus G. So M1 is going to be tension divided by A plus G. What was tension? 30-something, 35.4 divided by 9.8 plus 3.8. Don't know what the answer is. 35.4 divided by bracket 9.8 plus 3.8. Did you all get 2.6? 0 kilograms. Again, half mark for that, half mark for that, half mark for that, and a half mark for the answer. A student of mass big M places a bathroom scale on a skateboard. He then rolls forward on level ground while standing on the scale. First of all, I'm talking about a scale, but what am I really talking about here? Okay, normal force is what I'm envisioning. So if you roll forwards on level ground, does your normal force change? Or if you're sitting in a car and the car is traveling forwards, does your normal force change? Do you feel heavier or lighter? Zaina? So it's still going to just say M. What about B? More than M, less than M, or M? Convince me. Okay. Because it's mg, which trig function?
It's
Okay, so if you did a free body diagram, let's say, there's the kid on the skateboard going down. Oh, hang on. If you're going down, the wind goes in the other direction, doesn't it? You could say, okay, I'm going to have mg down, and you're going to say the scale reading is the normal force, and so it's going to be mg perpendicular, which is mg cos theta. So certainly one way to do this would be to realize, I don't know if you've noticed, cosine, the biggest cosine can be is 1. When is cosine 1? When theta is 90 degrees. In other words, when theta is 90 degrees, your normal force is just mg. Sorry, that's a lie. Cosine is 1 when theta is 0 degrees. I'm sorry, I said that backwards. Because when theta is 0 degrees, then you get cosine of 0, which is 1, and you get a normal of just mg. When theta is 90 degrees, you get a cosine of 90 is 0. You're in free fall, no normal force. So I'm not going to mark this. You're going to mark this yourself. But if you mentioned in your answer somewhere that we're talking about normal force, I'm okay with that. Or if you went straight to mg perpendicular and mentioned that it's going to be less than mg, if you did a good free body diagram, I would give you credit for that. If you're not sure, show it to me later, lawyer with me, and I'll tell you whether I give you 2 out of 2 or 1 out of 2 or whatever. I like example 4. I like example 4. Example 4 is a nice question. Assume no friction for the following question. If m1 equals 11 and m2 equals 10.5, find the acceleration. This is a job for a free body diagram. What are the forces acting on this? Get the obvious one. So I'm going to have this m1g tension, m2g pause. I guess the normal force would be at right angles, and I'll stop right about there. So here's mg perpendicular. I said normal force, the perpendicular component. And there is mg parallel, color, 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 color. And now I'm going to keep going. There is the normal force and tension. And is there friction? Problem. I don't know which way this is sliding. I don't know who's winning. But it seems to me that the tug of war is between that and that. It's between M1G and M2, and I didn't put 2's on here. That was dumb of me. 2. If I didn't put 2's on there, I would be like, that would be foolish. I would not be labeling. I would label things. It takes 1 second. The tug of war is between M1G and M2G parallel. I would just crunch it. M1G is 11 times 9.8, 107.8. M2G parallel, M2G, 2 lines. It's going to be 10.5 times 9.8 times sine 53, 82. And you know what? This is winning. M1G is the winner. I might even make a little note to myself. That's the direction of the acceleration. So who's winning? I would go M1G, now minus tension, plus tension, minus M2G parallel. That equals M all A. I might be tempted to stretch it out. No tension, always nice when I lose tension. And I would probably maybe even on this line go, because now I'm going to get this. M1G minus M2G sine theta all over M1 plus M2. I'm going to get A equals M1, 11, G, 9.8, minus M2, 10.5, times 9.8, times sine Mr. Dewick, sine Mr. Dewick, sine 58 all over 11 plus 10.5. Bracket 11 times 9.8 minus 10.5 times 9.8 sine 58, close bracket, divided by bracket 11 plus 10.5. Made a typo? Thank you. I just started to go look for that. I would have caught it, but I do owe you a candy. You caught a mistake. Double check to make sure I didn't make a typo. I think that looks right. Did you get 0.955? It's not accelerating much at all. These are almost in balance. If you got that right, 2 out of 2. Otherwise, I would probably give you a half mark if I saw that, a half mark if I saw that, a half mark for the numbers, and a half mark for the answer. Find the tension in the rope. Which mass would be way, 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 way easier to use to find the tension for the rope? Yeah. You can do it with M2, but I would use M1. It's way less cluttered. So I'm going to use M1. My equation there is going to be M1G minus tension equals M1A. I would swappy dance, and I'll get M1G minus M1A. That equals tension. So it's going to be M1, which was 11 times 9.8 minus 11 times 0.955. I'm going to use my answer button. 11 times 9.8 minus 11 times, answer button. Did you get 97.3 or am I wrong? Did I make a mistake? That's right. 97.3. Newtons. If you didn't get that, if you got something too big, maybe you have a plus sign. Check your winners and your losers and how you rewrote the equation. What would the minimum coefficient of friction need to be for this to be stationary? Well, first thing I said is this M2 is sliding up the ramp, so to hold it stationary, friction would have to be pointing down the ramp. So now I rewrote my equation, but it's a tie. You could go like this. M1G, the tensions are going to cancel, and so Lily, I didn't bother writing them. Minus M2G parallel minus friction. And you could say that equals 0, because A is 0. Or you could have said everything down the ramp has to equal everything up the ramp. I probably would have said everything down the ramp has to equal everything up the ramp, because it's a tie. Regardless, where is the mu hidden inside of? I'm going to get the mu by itself. So I suspect most of you did it that way, and so you said, I'm just going to plus the friction here. I'll have M1G minus M2G sine theta equals friction. Although friction is what times what? I might have, instead of writing friction, I might already have gone like that. I don't know the normal force. Oh, but look, another force the same size as the normal force. What? This is M2G perpendicular. How would I get the mu by itself? So I'm going to get a coefficient of friction of M1G minus M2G sine theta divided by M2G cos theta. It's going to be M1 11G 9.8 minus M2 10.5 G 9.8 sine, what was the angle? 58, thank you. all over M2 10.5, G 9.8, cos 58. Hopefully this works. Bracket 11 times 9. Oh, did it again. Oh, you're saying the G's actually cancel? You're right. I could have canceled out the G's because there is a G in everything on the right. In fact, there was a G in everything. And so if you canceled out the G's, that's totally acceptable. Again, if you're not sure, leave them in. You'll still get the same answer. So yeah, that's good. I can go like this then. 11 minus 10.5 sine 58, close bracket, divided by bracket 10.5 cos 58. And I get, did you all get 0.377? People nodding? Units, no units. By the way, before we turn the page, M1 was 11. Could M1 be smaller than M2 and still have M2 accelerate up the ramp? Yeah, because the tug of war is between M1G and M2G, two lines parallel. Or if we had something like this, with a mass right here and a mass dangling and a rope attaching them. Does this have to be bigger? Does M2, would you like a cough candy, kiddo? I might have one. So let's suppose that this was 5 kilograms and this was 3 kilograms. Will that accelerate? Yeah? What if there was friction here? It still might. It depends how big friction is. It would depend on mu. So you can't accelerate with a smaller mass. I had somebody asking me that earlier. Anyways, let's keep going. Next page. Oh, skiing. Free body diagram. MG. MG perpendicular. MG parallel. Normal force. And it wants me to find the coefficient of friction, so there is friction. I'm pretty sure friction is that way. Who's winning? Well, it looks like we're speeding up from rest, so I'm pretty sure, Lena, that MG parallel is winning. Friction is losing. That equals MA. It wants me to find the mu. The mu is hidden inside of friction, so I'm going to get friction by itself. I'm going to do a swappy dance. I'll get mg parallel minus ma equals, you know what, mu times the normal force. To get the mu by itself, I think I'm going to divide by the normal force. I'm going to get mu equals mg, two lines is sine theta, minus ma, all over. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. It's mg perpendicular. It's mg cos theta. You know, there's an m in everything. I probably could have crossed out the m's, even though I gave you the mass of the skier. If there's an m in everything on one side, you can cross them out. And again, let me emphasize, if you're not sure because you're a little shaky on fractions, don't cross it out. You'll still get the right answer. I tend to be lazy. Oh, why can't I solve this? Yeah, even though this question said find mu, I'm going to now spend some time finding a. So I'm going to go a equals question mark. It looks like they told me VI was 0, VF was 20, and T was 8. So A is going to be VF minus VI over T. It's going to be 20 over 8. I can do that in my head. It's going to be 10 over 4. It's going to be 5 over 2. Looks like A is 2.5 meters per second squared, and I can plug this in over here now. I'll get mu equals G 9.8 sine 16 minus 2.5 all over 9.8 cos 16. Sine 16 minus 2.5 close bracket divided by bracket 9.8 cos 16. Do you all get 0.021? So 0.0214 if I round up properly. Is that big? I got nervous at first, but then wait a minute, we're skiing. There shouldn't be a lot of friction. I'm okay with this. If you got that, 4 out of 4. Otherwise, I would give you half mark if I saw that, half mark if I saw that, half mark for the numbers, half mark for the answer, 1 mark for that, half mark for the numbers, half mark for that. Someone's phone's made a noise now twice. Really does sound like it's coming from over there. Let me hit pause for a second. This is kind of a neat question. Prevents it from moving. If we're not moving, what's A? That's probably going to be handy. I'm going to make a little note. I'm going to do a free body. Oh, it says to draw the free body diagram. Now, since they gave me space, I'm going to draw the free body diagram right here. If you label this, I'll be okay, but I'll tell you what I would be looking for. So I would first of all represent the mass with a dot. What are the forces acting on this? We have gravity down. And then I would probably pause and I would put F applied. What else? Is the normal force bigger, smaller, or the same size as mg? So however you drew your free body diagram, I would need to see that the normal force was clearly and obviously smaller than mg. What else? Friction which way? Why would that be wrong? Yeah, because A is 0, also, why would that be wrong? I would be looking for something that was the same length approximately as fx. So for you to get 2 marks, half mark for each of the 4 lines, I would look for 4 lines and I would say I need normal force to be smaller than mg, if not, minus 0.5. I would need F applied there. I would need fx to be the same size as friction to be the same size as fx. You had a hand up. You didn't? No? Okay. All right. What does B want me to find? Friction. Okay. My first thought was to do this. Why doesn't that work? I don't know mu. I can figure out Fm, but I don't know mu. In fact, what's part D asking me to find? You know what? How else can I figure out friction? Maybe from an equation. Who's winning? Well, since A is 0, it's a tie. So what you really have is this. Fx equals friction. That's how I can find friction. Fx, which trig function is Fx? Color. Adjacent hypotenuse. It's cosine. So friction ends up being F applied cos theta. It's going to be, how big was F applied? 140 cos 28. Friction is 123.6. I'm going to call it 124 newtons. So that's an unusual one. You're finding friction by reversing the procedure. Usually I give you mu, find friction. Here I've told you that, and then use friction to find acceleration. Here I've told you the acceleration, work your way backwards. How big does friction have to be? What's the normal force? Well, for the normal force, everything down, which is mg, has to equal everything up, which is the normal force and Fy. To get the normal force by itself, the normal force is going to be mg minus Fy, FYI. How do I get the F, or what's the Fy? The Fy ends up being sine. So I'm going to get this. Normal force is mg minus F applied sine theta. It's going to be m. What was m, Mr. Dewick? 55. G minus 140 sine 28. The normal force is going to be 55 times 9.8 minus 140 sine 28. And I get a normal force of 473.3, 473, is that right? People nodding? 473 newtons. Then, last thing it wants is mu. Well, mu is friction divided by the normal force. It's going to be 124 divided by 473, but I'm going to see if I can carry some extra sig figs. It's actually 123.613 divided by answer button, and I get a coefficient of friction of 0.261. I'd take 0.260 or 0.262. And mu has no units. Can you give yourself a score, please, out of 29? If you need to lawyer with me, now is the time.